Hello everyone, today we're gonna do something pretty cool. I've got a paper right here with some limits problems, okay? And we're gonna solve those problems. These problems, you need to factor in all of them or do something that is pretty cool, okay? It's not just direct substitution, which, come on, it's kind of boring. So, I have my bottle of water here because I get thirsty sometimes speaking. And I really want to do this very comfortable, so you should also go and get comfy at home and, just get a paper and we're going to do some problems together. So let's start. So the first problem that we're going to have is the following. We're going to have the limit. We're going to have the limit as x approaches 0 in the equation 5x over x squared plus 2x. So clearly we cannot do direct substitution, we would get 0. So if you see, what we can do is we have a common factor here in these terms and also up here, x. So we're going to take it out. We can't do anything else up here, but what we can do here is we can take the greatest factor, that would be x. So we take x times x plus 2 over 5x. Now this x cancel out, and you would get that this is equal to 5 over x plus 2. And now we can plug in 0 in this equation. This would be simply 5 over 0 plus 2, which is just simply equal to 5 over 2. This is our first problem. I'm gonna erase each problem so that I can write on top of here and I don't have to start going down here, just so we're comfortable. The next problem that we have is we're gonna take the limit as x approaches 2 in the function x squared plus 3x minus 10 over x minus 2. So how do we factor this? Well, we can't do anything down there, but what we can do is, we know we can factor this out somehow. So we need two numbers that multiplied give me 10 and that added together give me 3. That is simply 5 and 2. So we're gonna do that. So we're gonna open our two parentheses. And what we're gonna do is we're gonna place, x plus, and now multiply the two signs, so we get minus, we get x minus, and now we need 5 minus 2 would give us 3, right? So we know that 2 needs to be negative. So we place a 2 right here, and the 5 goes in here. And now, well, you see what we do here. We have x minus 2, and these 2, they go out, and we get that this is equal to x plus 5. Now we can plug in 2, and so we would get that 2 plus 5, that's just simply equal to 7. Pretty cool. Now our next limit, we're gonna take, let's see how it goes. So we have the limit, once again, as x approaches 3 in the function. This is a pretty easy one. I hope that you guys can see what we need to do here pretty much straight away. What do we do here? Well, we know 9 is a pretty cool number because it is a square of another number. We know it's 3 squared. So we're just simply gonna factor this as a difference of perfect squares. So we have x plus 3 times x minus 9 over x minus 3. And we know that would give us never mind. Yeah, I'm sorry. I saw this and I was like, oh, why can I not cancel? This is a 3. This is a 3. These two go out and you get x plus 3. Now we plug in 3 in there and we get this is gonna be equal to 3 plus 3, so that's 6. Pretty cool. Our next problem, let's see how it goes. we're gonna get, oh, another one pretty similar. We get limit as x approaches to in the function x cubed minus 8 over x minus 2. So how do we solve this? I hope you guys see how this in some sort of way resembles what we did before. So this is a difference of perfect cubes. We know this is the cube of 2. So we just take that as a difference of cubes. I'm gonna write the rule right here that you need to follow. Just so you remember, I'm gonna write it down here. We're gonna have that. Yeah, this is gonna be equal to 2 to the cube, 2 to the third power, and now this is equal to. So we open two of our brackets, and we say that this is x minus 2. Remember, the same sign goes in the first one, the first parenthesis. And then we go that x squared plus the opposite sign, the 2 times, well, the product, no, not 2 times, just remember here goes a coefficient of 1. So we have the multiplication between the two terms plus the second term squared, which would be 2 squared, and that's just 4. And we close the parentheses. So now, my other marker here. So now we just plug in this on top, so we would get x minus 2 times x squared plus 2x plus 4 over, we get x minus 2, pretty amazing, these two cancel out, of course, and now we're gonna have x squared plus 2x plus 4. This should be a plus. It's kind of like squiggly, it looks like an x. So this is plus 4, and now we plug in 2, we would get 2 squared 4, this is also 4 times 3, we get 12. There we go. Now let's erase this. Our second problem would be, oh, this is a pretty cool problem, so, okay, let me show you. When I was writing this problem, I really thought that it would be pretty amazing to, to show you how you're supposed to solve it. So you get the limit as x approaches 4 in the function 4 minus x over x squared minus 16. So how do you do this? Well, it's pretty cool. So try to pause the video for a moment and try solving this. So if you see, you might think that, well, we can just simply, take a difference of perfect squares down there, and well, let's do that. And then maybe we might be able to cancel out something, but as you may have realized already, that's not the case. This would be our factorization. And now you see, we cannot really cancel out anything here, because this is the same as minus x plus 4, and we do not have any x here with a negative sign, okay? So that means that we can't cancel out anything. What we can actually do is the following. We can take, math is pretty cool because there are things that you may not see, but they are there. If you think about it, this is a product of a multiplication by minus 1. Check this out. So from this we can factor out minus 1, and we would get something pretty amazing. So if we take out minus 1 from here, well, so we can go back. I mean, what do we need to go back to this expression? Well, we know that would be minus 4, because minus 1 times minus 4, that would give you positive 4, minus x, so that would be plus x, over, now you see how cool this is. Now you got x minus 4 times x plus 4, and you see these two babies right here, they cancel out. This is the same as x minus 4, and you have x minus 4 here, so they go out. And you get minus 1 on top. So you get minus 1 over x plus 4, and now we can plug in 4 in there, so we get minus 1 over 8, 4 plus 4. Now it is pretty amazing because we just, it might not be that obvious that there is a minus 1 implicitly in that thing, but there is, and you can use it to, you know, factor out things. It's pretty cool. It's pretty cool. Our next problem goes. I'm sorry. Hopefully that won't fall. The camera won't fall. Next problem that we have is. Oh, this is also a pretty good one. We're gonna have the limit as x approaches -4 in the function x squared minus x minus 12 over x squared plus x minus 20. So how do we do this? Well, you might already see the form. What we need to do, we've got polynomials here. In the previous video, I actually showed you how you were supposed to factor those out. Let's do them. We would get our two parentheses. Now first sign that would be minus. No, we open. Yeah, let's open our second parentheses. Multiplication of the two signs that gives us plus, and then we close it. So we need two numbers that multiplied gives us 12, and that added together give us 1. Now how much is that? Well, pretty simple. We know it's 4 and minus 3. They give us minus 12, and added together they give us a 1. Yeah, they give us 1. So we would get 4 and 3. Pretty amazing. Actually, no, this is supposed to be, never mind. This is supposed to be minus 1. So we should get minus 1 also as an addition. Yeah. Hopefully you caught that error before me. It should be 3. Oh no, never mind. That's the same thing I wrote. Oh shit. Oh my god. Okay. It is fine. So we would get, this is minus 4, yes, and 3. I hope you guys can see that you need to be very careful when you factor this out. The coefficient that is here, or the constant, they need to have the same sign, okay? When you factor this out, you need to be very careful that the addition of these two gives you the coefficient with the right sign, okay? In this case, you get minus 4 plus 3, that gives you minus 1, which is minus x in this case. So you need to be careful. So let's keep going. We factor this out by, again, we have two parentheses, and we're gonna have first sign in the first parentheses. Now multiplication of the two of them, that would give, that's a plus sign, right? Yeah. That would give us minus, x minus. And now two numbers that multiply give me 20, and that added together give me positive 1. Well, multiply give me minus 20, added together give me 1. We know that is 5 and 4. 5 and minus 4. No, I need to specify that. 5 and minus 4, okay? Together, they give me, multiplied, give me minus 20. Added together, they give me positive 1. So we're, oh yeah, I haven't solved it yet. And we have these, how do we cancel out? These two cancel out, and we would get x plus 3 over x plus 5. We plug in 4 in there, we will get 4 plus 3, that's 7 over 9. This is your answer. Let's do another example. So our following problem would be, now we're gonna go to something that we need to do a pretty cool algebra thing that is called the greatest common denominator. I hope you guys know what that is. And if you don't know, well, maybe you can learn from this video with what it is. So let's do this problem. So we get the limit as x approaches minus 4 in the function 1 over 4 plus 1 over x over 4 plus x. Once again, we cannot plug minus 4 into the function. So we need to do something pretty cool. First of all, how do we simplify what's up here? We need to find the greatest common denominator. And we do that the following way. So I'm gonna show you like the form so you can remember. So imagine you have a over b plus or minus. You can have both operations if you want. And now I'm gonna write this in the other color so it's better. C over d. The greatest common denominator between these two fractions is equal to the product, you could say, of each of the four parts that you have in the expression. By a part, I mean a numerator, and two denominators. So let me show you. You just simply need to multiply. So yeah, this would be equal to, I'm gonna do with this. So the greatest common denominator would be equal to A times D. So you grab the denominator on the other side and you multiply it by the numerator over, this goes over B times D, once again. Okay, so you grab the denominator and you multiply it in the top and in the bottom, so you can find the greatest common denominator. We get plus minus, and now you do the same thing on here. So what you need to do is you're gonna get C over D times the denominator of your other fraction. So that would be B. Now if you see these two denominators, they're the same thing. So eventually what you would get is just simply an expression that goes like this. So now I'm gonna go with like you would get simply this is equal to a times D plus or minus C times B over D. Okay? So that's how you find B times D is the greatest common denominator in this operation of fractions right there. Okay? That these two fractions individually share with each other. So now how do we bring this up here? Well, it's pretty simple. We need to do the same process we did with these two fractions. So we would get from here that so we multiply x top and bottom and we get x over 4x plus we multiply 4 top and bottom, so we get 4 over 4x, right? And now we have the same denominator. We get down here we get 4 plus x. Now we have the same denominator here, so let's just have x plus 4 over 4x and over x plus 4, just so we have the same form, x plus 4. Okay, pretty cool. Now what do? There is something that you need to know when you're dividing a fraction by another fraction, because this is also a fraction. You just simply have here over 1. There is a pretty amazing and very useful rule that exists, that is the following. If we have a division A over B, this is the same as if I multiplied A times the inverse of B, okay, which is just B to the minus 1 or 1 over B, okay. Now how does that help us here? Well, this means that from this we can say that if we want to divide this fraction by this fraction, we can multiply the same thing that we did here by the inverse operation. Or no, well, not the inverse operation, it's actually like the inverse form, like, yeah, 1 over whatever we have. So we go here that this is equal to us getting x plus 4 over 4x times the inverse of this, which we know, this is a times, which we know is going to be equal to 1 over x plus 4. Okay? That's how it goes. And I think you guys see it now. These two, they cross out, and we would get simply that this is equal to 1 over 4x. And now we can plug in minus 4 in here, we get no problem. And this would be equal to 1 times 4, to 1 over 4 times minus 4, which is the same as if we had 1 over minus 16, minus 1 over 16. Okay? So this is our answer. Let me erase all of this. I really hope that you learned something if you didn't know about the greatest common denominator. This is something that is pretty common in the SAT, because a lot of times they just simply want to see that you can do maths and that you know how to simplify things, okay? It is also very common when you have a fraction divided something else and you take you do that by simply the fraction times the inverse of the denominator you're taking now. So it's pretty cool and it's pretty useful. Our next problem is the following. We're gonna have the limit. This looks like a derivative because, I mean, it is actually derivative. Yeah, now I didn't see it when I wrote it, but yeah, it's actually derivative. A derivative by definition, you know. We have as h approaches to 0 in the function 3 plus h. Well, technically, no, I mean, well, yeah, it's a function. To minus 1 minus to the minus 1, yeah, to minus 3 to the minus 1 over h. So what do we do here? Once again, if you see, we need to do something very similar as we did before. So we know this is going to be equal to, this is the inverse. So we're going to take 3 plus h, I'm sorry, it should be 1 over 3 plus h minus, oh no, remember what I wrote the minus down there. Minus 1 over 3 over h. Right? And now we do the same thing that we did before. We take the greatest common denominator. So this is going to be equal to 3 times top and bottom. So we get 3 over 3. Now this should be equal to, I'll cross the terms later. 3 times 3 plus h minus, now 3 plus h times top and bottom. So we get 3 plus h over, same thing, 3 times 3 plus h over h. Now let's keep going down here. So we would get this is equal to, that is equal to, yeah, we just get this. So we get 3 minus 3 plus h over, we get the same thing, now we cross it, so we get 9 plus 3h over h. Once again, what we can do here is we just simply take, we're dividing by this, so it's the same as if we multiplied by the inverse. So we're gonna have these two 3's, they go out, pretty cool, and we get that this is gonna be equal to h over 9 plus 3h times the inverse of h, which is just 1 over h, which is the same as these 2h, they go out, and we get 1 over 9 plus 3h. And now we can plug in 0 in here. We get no problems. We get 1 over 9 plus 3 times 0, that's just simply going to be 0. And we get 1 over 9. That is our answer. Okay, I hope that you're seeing how useful it is to know about the greatest common denominator. A lot of times you're going to get functions like this, and well, you need to know how they go and you know what are like the techniques that are very useful in solving them. We also have sort of a derivative too, and something pretty cool. Okay, this is gonna be our last problem. So we have the limit as h approaches 0 in the function 4 plus h squared minus 16 over h. Now I hope you see something pretty amazing here. We can take this as a difference of squares because we have a term squared minus a term squared, which is 4 squared, and maybe we could see if we can cross out something down there with the bottom. Or something we can do is we could expand this as a binomial, a binomial expansion, and see what goes on. So let's try both of them. So I'm gonna write difference of squares. Just here So we know the two solutions that we are suggesting. So we have difference of squares. I'm just gonna write difference of squares like that. And let's see how it goes. So we would get something like that would be equal to, so for a difference of squares we would take first term, which is 4 plus h minus square root of the first term, which is 4, times, now that same thing but with a positive sign, so it goes 4 over h. We get h here. And now let's see what we can cross here. So the 4's, they would go out, so we would get h. The 4's go out, we get h times, that would be 8 plus h. 8 times, h times 8 plus h over h. Now something pretty cool we can do there. Well, we can cancel out, yeah, the h and yeah, okay. We can the h, they go out and we get 8 plus h. Now we plug in the number that we had, that would be 0. So again, this is just simply 8. Now this is for the difference of squares. Now let's see what happens if we do a binomial expansion. So I'm just gonna say binomial expansion. So now we're gonna take we have this. So yeah, let's expand that. So we have the limit as h approaches 0. Now let's expand it. So we would have square of the first term, that is 16, plus 2 times the two terms, this would be 8h plus 8h, plus square of the second term, which would be h squared, minus 16 over h. Now we get to the same point that we got here. So you see the 16 goes out with minus 16, you get 8h plus h squared over h. You take the common factor, the greatest common factor, and you get h times 8 plus h over h. This is the same thing that we had up here. And the h, they go out, and you get 8 plus h. And this is simply equal to, we plug in again our same number, and we get 8. Well, we plug in 0, and we get 8. Same thing that we got in here. So I believe, yep, that would be all of our problems today. I hope that you guys enjoyed it. This was pretty cool for me. I hope you guys, it was pretty cool for you too, I guess. And I hope. And see you guys in the next one.